All right, Mike, we're joined now by Samantha Johnson. She's the founder and CEO of Tatum Robotics. Tatum Robotics is a Boston-based robotics startup. They're building an independent communication tool for people with deaf blindness. For those who are not familiar with that, deaf-blind individuals, they can't see and they also can't hear. So Tatum Robotics actually took home first place at our Pitchfire robotics startup competition just under a month ago at RoboBusiness. So Samantha's here to tell us all about her company, her solution, how she got started down this path. She has a real passion for this, so it's pretty cool. So Samantha, first off, thank you for being here. How are you doing?
Great. Thank you for having me. Looking forward to this.
Yeah, no, our pleasure. I think the first place to start is just sort of introduce yourself to the audience. Tell us a little bit about yourself, your background, and then we'll get into the technology here in a few.
Yeah, absolutely. So as you mentioned, I'm the founder and CEO of Tatum Robotics. Tatum Robotics was founded about a year ago with the goal to bring the first independent communication tool to the deafblind individuals. And deafblind individuals, as you mentioned, they can't hear nor see, and the way that they communicate then is through tactile sign languages. So instead of visual sign languages, as you can imagine, they're just kind of speaking to the person in front of them. Instead, they actually hold on to the hand of their signing partner and receive the signs into their palm. And I first became aware of kind of the deafblind communication vacuum actually in a class that I was taking during my undergraduate at Northeastern University. Although I was studying bioengineering, I was interested in assistive technology and disability communities. So I was taking a sign language class and I met a deafblind woman during that class. And in working with her and communicating with her, I learned that she does not access Braille, which is very common for deafblind folks, especially those who become deafblind later in life and don't have access to education or maybe have multiple disabilities. And as a result, if she did not have an interpreter directly next to her or a communication partner that knew how to sign directly next to her, she was not able to communicate with them. So as I continued my education, the COVID pandemic came around and social distancing was a huge hit to this community, as you could imagine. As interpreting services stopped, deafblind people were completely out of access to news, resources, healthcare, and we really ramped up at that point. I started as my master's thesis, and after graduating, that's when I founded the company, pulled a team together, and have been developing ever since.
Interesting. So how big is this community of deafblind folks worldwide? In other words, I mean, how big is your market for this opportunity beyond just sort of the life-changing parts that we're going to talk about in terms of what it does?
Yeah, absolutely. And I think that's something people are always surprised to hear. I think if you can think of somebody with deafblindness, you think of Helen Keller, but in worldwide, they say approximately 0.2% of the population has deafblindness, severe deafblindness. And in the US, there's actually a much higher population, so about 0.8% have severe deafblindness. And it can equate to about like 100 million people worldwide who have hearing and visual impairments. And of course, this can be a range, so that can be, hard of hearing and low vision to complete deafness and complete blindness. So we're really targeting with this technology, specifically those with severe deafblindness, so that like 0.2 and 0.8%. And we assume that there's a higher prevalence in the United States also because we do have the infrastructure here, the education, that people who do have deafblindness tend to come to the US for education and some support.
If you can, I think a lot of us take for granted our faculties that we have that work well, right? Just take us, how limited is somebody with deaf blindness? I mean, their day-to-day is just so completely different than anything that you or I can imagine dealing with. And the best that you can, just sort of tell us, how do they go about their day? I know they rely, which is why you're doing this, they rely so much on other people to help them get through their day. Just sort of paint that picture for us as much as you can.
Yeah, absolutely. I have actually a really interesting story. There's a deafblind woman we work with pretty frequently. And the first time we went to go visit her home, we had met her in person and she mentioned to meet her at her home at 11 a.m. And me and one of my employees showed up at her home and we wondered, how do we tell her that we've arrived? We can't ring the doorbell or knock on the door. And we just waited outside. And eventually she wandered out and we grabbed her arm and began signing with her. And I asked him, like, how would you have known if somebody was outside? And she doesn't know what time it is. She doesn't know that it's 11 and therefore we should have arrived.
Wow.
And she mentioned that if the door is unlocked, people just come in. And we're like, wow. So imagine someone just comes up behind you and grabs your arm and that's how you know somebody is in your home. And we walk into this woman's home, all the lights are off, she can't see, it doesn't really matter if there's lights on. And she was just sitting at her table waiting for us to arrive. And I think that really is a lot of the consensus that we've heard from the deafblind population, is just the boredom factor is really what we're really trying to support as well, that access to entertainment, because boredom and isolation really does lead to mental health problems as well and challenges. So although some deafblind people absolutely have jobs, are very engaged in their community, there is so much downtime in the deafblind community that, because again, they don't have someone in their immediate contact to communicate with, they don't have access. So that's something that, as we've met more and more deafblind people, what they're really excited about is being able to read a book or access some sort of, community outreach, like have a phone call or a text message with their peers.
Well, you mentioned before that Braille, although they tactile, they can touch and feel. You mentioned that that's not necessarily prevalent for a larger part of the community. Can you explain that a little bit deeper?
Yeah, absolutely. So there are definitely people who are deafblind who can access Braille, but for the most part, if you do not have education from a really early stage, you won't learn Braille at that point. And also a lot of people with deafblindness may also have cognitive disabilities, so there might be that limiting factor. But really the biggest factor that we found with deafblindness is usually you have deafblindness through conditions such as Usher syndrome or Charge syndrome. And because of that, you actually lose your vision when you're 30s, 40s. And it gets to a point that your fingertips really just don't have the tactile sensation anymore to receive it. And it's just harder and harder to learn. And as a result, people don't pick it up as quickly. And we found actually a big population that we work with, deafblind tactile American Sign Language, it's sign-based, not English-based, whereas Braille is based in English. So it's all just spell. It's a modality of English. So it's everything is spelled just like English, but a lot of people don't know how to spell these words because they're used to receiving the signs for them. One of our first actually validations is we have our tactile signing system, and we were finger spelling some words. And we were spelling, I don't know what word it was, maybe frog. And the deafblind woman we were working with was like, I don't know what word it is. I can't know. I'm like, okay, let's go through the letters individually. And she spelled F-R-O-G. And I was like, great, what does that spell? And she says, I have no idea. And that really shows that if they were access Braille, even if they could read the letters, they wouldn't be able to easily put together what that spells, just because they don't have that in their back pocket. That's haven't been what they've been using up until this point.
This is a fascinating conversation for me. So my wife is a teacher by trade, right? So she's kind of stepped back since we had little kids. And what she's done for the last year or so is she's become a reading tutor in town. Now, this is with kids who, young kids, second, third grade, they can see and they can hear, right? So they don't have any, their faculties on those fronts work perfectly fine, but they have such a hard time reading because of I think the pandemic has played a part in that, but I think our town may be quite far behind on the type of curriculum that they're using to help these kids read, right? It works for the kids who pick it up easily, it works really well, but for the kids where it doesn't work, there's a major gap in helping those kids who need a little bit extra help. So when you mentioned that this person didn't know what F-R-O-G spelled, it's just like, to me, like a bell went off. It's like, holy smokes, if these young kids are falling way behind, and there's, you said 0.2% or whatever, very small percentage of people have deaf blindness, the complete lack of support educationally for them must be astounding.
Right, absolutely. There are so few institutions really that deafblind students can really go to. Perkins School, especially when in Watertown, being a huge, if you have a child with deaf blindness, Perkins is informed and usually involved in the intervention with that child. But even just as you mentioned, learning literacy is hard for disabled students, and signing, especially American Sign Language, has been used a lot in those practices to help support literacy, and especially with students with autism or other cognitive disabilities. So as it's used in deaf blindness is a little bit different, especially with those kids at Perkins. Teaching children who are deaf and blind concepts can be very hard, especially like tangible things. You can hand a deafblind person a cup and you could then tell them the sign. But we were once asking them about what do you dream about? What do deafblind children dream about and adults dream about? And how do you convey the idea of a dream to somebody? It's so intangible. And so that's really, again, the literacy factor. We can't give them the sign for it. It's hard to explain. And now we want them to know the word. So there's just so many factors that come into play there.
Interesting. So let's talk about what it is that you've invented and how that is going to change the lives of these folks. So tell us about the solution.
Yeah, absolutely. So what we wanted to do was really try to preserve as much of signing culture that we really could. So deaf-blind people communicate through tactile sign primarily. And as we mentioned, they hold on to the hand of their communication partner and they receive the signs directly into their palm. It looks quite like magic. And it works very well for them. And we really didn't want to come in, especially as abled engineers, and transform the way that they communicate. We want to really preserve as much of that culture because so much of deaf-blind culture is in the language that they use. And so what we did is we've developed these highly collaborative anthropomorphic robotics. So designed out of all flexible materials, we've made a 18 degree of freedom hand wrist that we're actually able to input, for example, the word frog, and it will sign the word frog. And that deafblind person can hold on to it to receive the signs into their hand. And this will really help them get access to not only entertainment, we're pulling books, ebooks, and we translate them out of ASL out of English into ASL to really, again, preserve that language, because English and ASL, again, are two completely different languages. So we've developed our own novel translation between the two languages, output onto the device that the deafblind person is able to hold on to access books. You, as a non-signer, could sit there and type to talk with them and have receiving back and forth to actually create these new modalities of communication for these deafblind folks while still preserving tactile sign the way that they're used to.
So it's a robotic hand that's recreating the tactile sign language that somebody with deaf blindness would have to pay for an expert, or somebody in their family would have to be trained to do. This is another basically way for them to receive that communication.
Right, exactly. We view it as a supplemental tool for interpreters. So interpreters are quite amazing at what they do. They're, again, the people that deafblind people really call to if they were trying to interact with somebody who does not sign. However, interpreters, as you can imagine, are very expensive because they are so good at what they do. And there's just shortages of them. So you can't just have an interpreter at your side at all moments. So we don't want this in any way to replace interpreters, but really to supplement their work. So that if you go out, you could still have an interpreter, but if you're in your home, you could now have this independence that you wouldn't have before. Or in education, when you can't always have a teacher by your side, you could have this as a tool to really augment that.
Yeah, let me ask this question. So what's been the reaction of folks the first time they've touched this device in your prototype? I mean, you explain them, they have no idea what a robot is to begin with, let alone this creepy, disconnected hand that moves like a human hand. How have you explained that, and what's been the reactions of some of the folks?
Yeah, absolutely. So definitely the first time we brought in deafblind folks, when the prototypes were so super early stage, you brought up a good point that deafblind people do not have experience with robotics nor technology as a generalism.
Yeah.
And so we asked them to hold on to this robot, and a lot of them like, whoa, you can see the shock in their eyes, and they just try to pick it up and lift it around. Just like if you handed somebody something they've never seen before, they spin it around, try to feel all the edges. And what's been so exciting, especially as the prototypes have gotten so much better and have really been able to recapitulate these signs so much better, is the excitement that these deafblind people see. We have people crying in our offices, really talking about how this could be so life-changing. We have people try to steal them off the desks when they leave because they want them in their homes. They can see that it can be beneficial. And I think that is really rewarding as well for us as engineers to know that we're going in the right direction as well. That not only are we making a tool that's cool in robotics, low cost, anthropomorphic, collaborative, but it's also going to be really useful at the end of the day for these deafblind folks who really see that this could be really rewarding.
That story of them trying to steal them off that reminds me of, you see, and I probably cry every time I see these videos, there's a video of a young person, a young kid, and they're deaf. And then they get these new ear implants, and they hear their parents' voice for the first time, or they get these special glasses that let them see color for the first time. It's a magical experience, right? Yeah. And again, things that we on this call just take for granted so much, right? So this is super cool. Can you tell us a little bit more about the hand itself? If we can share videos, on the website when we run this podcast, that would be great, because I think that will help people certainly see exactly what it is that you're doing. But the hand itself is super sophisticated with all the different joints and the flexibility that is required for it being able to replicate this tactile sign language.
Yeah, absolutely. And that's something when I actually first got started with this project, I had the idea and I imagined it was really going to be more of a software project than anything else. Because I imagined we could take an off-the-shelf hand and just kind of design it how we needed to in terms of the transitions and the hand shapes and the algorithms that way. But what we quickly found was the dexterity needed to really create the hand shapes for American Sign Language is quite intense. So every finger that we've designed actually has 3 degrees of freedom. So our MCP has its own degree of freedom, the coupled DIP, PIP, abduction, because each hand shape is so different that if each finger does not have that dexterity, it's not able to achieve them, especially differentiating between them. And another big factor is safety as well. As you could imagine, these deafblind people cannot hear the machine moving, they can't see the machine moving. So we really need to make sure that no matter what happens, they can't get stuck in, rigid joints that are made of metal or linkages that create gapping as they flex and extend. So we've created this system that's all one solid print for these fingers that we're currently printing, but we're actually moving to casting, but it's all one solid piece so that there's no gaps that create that they could get stuck in, because again, they're holding on to it as it's moving. So we've designed it in a way that can achieve all these different configurations while still being made in a way that would be safe for those users and compliant that way.
And I can imagine speed. You talk about just how you did your hand. Today, grippers move pretty slow, or pneumatic grippers are bang, bang type of thing. But to have that dexterity to actually move fast and to keep up with a conversation, with the hearing person in real time, for example. Yeah.
Yeah, absolutely. Signing is not slow. It's one of those things that American Sign Language is really, you could have a conversation on pace with an English speaker. And so as we're developing our actuators and making sure all of our actuation schemes are in place, it needs to be able to move fast. We don't want this to be inefficient for them to use. So as we've, chosen, we are prioritizing the cost because, as you mentioned, this needs to be accessible for deafblind people. So we have to work through government grant programs in that case stay within their pricing guidelines. So we have to use these very fast actuators to make sure that it can achieve the hand shapes in good time, but also make sure that each of the hand shapes is very precise. So we're actually mapping these hand shapes from deaf and native signers. So we bring them in, do motion capture and map them onto the device themselves so that it's not just, us again, abled, hearing, sighted people mapping these hand shapes. It's really a true signer that is actually recapitulating these hand shapes onto the
I wanted to ask you about that because it is still then a software play for sure, but I was trying to figure out how are you programming each individual letter into so you're not doing that. You're taking not that it's not easy, but it simplifies that process for you guys significantly, I would think.
Yeah, absolutely. Because again, American Sign Language, it has a 26-letter alphabet. However, it also has a whole dictionary of signs, just like English does. So our fingerspelling hand does the fingerspelling. So again, you would spell frog, but our hand also plugs into, we're making a whole 4 degree of freedom arm as well. So it can really do complex signing. And in that case, there's thousands and thousands of signs. So if we had to manually program those, not only would it be inefficient, but it wouldn't really capture the fluidity of sign. So by bringing in these deaf native signers, we're able to capture those signs much more accurately in the movements that are associated with them.
So interesting. And one of the things you mentioned earlier, then I can have in my mind now what this device is ultimately going to look like for someone to use. But what's your plan then for integrating, to mainstream entertainment? Then you talk about ebooks. You talk about, I can imagine, some sort of interface for me if I'm communicating with an individual that I could talk and it would translate, and then they would talk, sign, and then it would speak back to me. Is something like that going to be possible with this? What's your vision?
Yeah, so there's a lot of functionalities. We're starting with text-based communication mediums, mainly because of the needs of our translation algorithm. So we're developing a custom, essentially Google Translate, to move between the 2 languages. So as you can imagine, that's much easier when the language is written accurately. You go from text to speech to text, you're going to get some mistakes in there. So we're taking ebooks, especially we're using even like Spark Notes. So we can get, if they want the long version of the text, we could give them a short version of the text. And our whole software for the whole system is essentially cloud-based. We have a whole small, very thin robot client that essentially just moves the servos, but everything else is stored up in the cloud. So we can have the system be very custom. So not only can they choose the signing speed, their grammar, their vocabulary, but again, we can easily pull that ebook run it through our translation algorithm to move it out of English into the ASL that they prefer, whether that be more English, more Pidgin, true ASL, and then output it. But not only do we want this, we don't want it to only be a one-way communication stream. So as you mentioned, having this allowed for communication with non-signers, we're also developing out a gesture recognition software. So you would be able to speak, it would translate output onto tactile sign. And then as a deafblind person signs to response, our gesture recognition would be able to capture that and then send that back to you. So it would allow for you to communicate with a deafblind person. It would allow for two deafblind people to communicate with each other from afar, which they can't do right now. They can't communicate with their friends from afar. They can't call or text their friends. So now it's something that opens up the world for them that way as well.
You're democratizing, the ability for someone to communicate with a deafblind person.
Right. Their community suddenly isn't just the, very small population that knows tactile American Sign Language. It's now truly anybody who wants to communicate with a deafblind person.
Wow, that's crazy. Can you go back to the motion capture for the use? Can you just explain a little bit for myself how you're doing that?
Yeah, so we wanted the gesture recognition to not only allow for, again, deafblind people to interact with the greater community, but also for them to interact with the device itself. So we don't want to have a complex series of buttons that they need to try to interact with. Again, they don't have a lot of familiarity with technology, so that would be a complex system. So we also wanted it to be able to interact with the device via gesture recognition. So they can just sign to the device, I want to read a book, and then they're able to access it that way. So we're doing we're doing motion tracking for multiple purposes. So we're doing motion tracking for the gesture recognition. So we have to, have multiple cameras that we overlay to each other to get accurate axes, but also we're doing that to track the hand shapes. And we've been working with a lot of partners in terms of actually trying to capture those movements more accurately. We have computer scientists, we have animators, we have deaf people that come in and really trying to make sure that those movements that we put onto the robot are accurate, and our software makes sure that they're safe. So we can control the speeds of our motors. We can make sure that they're back drivable to make sure that as we put those movements onto the motors, that it's not only making the hand shape for the deafblind person, but it can change as their environments change as well.
I'm really beginning to understand you've got a system here you've got an AI and software component, and then the robotics aspect of this is really an incredible challenge, way more than I understood in the 2 minutes you had to tell us about this at RoboBusiness. So what have been some of the challenges then you've had to overcome getting the prototype built? And I assume some of that's money as well, but just for a startup at your stage, what have you had to overcome to get to this point now?
Yeah, absolutely. I think you hit an important point there, that there are just so many novel components as to what we're doing. So we're developing novel translation algorithms. We're also developing compliant robotics. We're developing this gesture recognition software. So there's so many moving parts that really also requires a very diverse team. So our team has software engineers, hardware engineers, but also linguists, deaf signers, native signers. So there is just so many people on the team. But starting with the hardware, a huge challenge was designing for people who cannot hear or see. And we as hearing sighted engineers don't always know those answers. And I remember one of our first prototypes, I developed out this silicone glove that I thought they would love because it felt so human-like. And the deafblind people wouldn't even touch it. They thought it felt like a monster. And here I was like, I've found the perfect solution to the problem, and they hated it.
I was actually going to ask you that, because even with the hand that you have now, like, what does it feel like? It's got to be hard, right?
It's actually all TPU right now.
Okay.
And we're looking into some urethane options as well. So it is all flexibles. There's no rigid components in the hand itself, again, for that safety factor. But again, designing especially early stage prototypes that have only flexibles, you're really limited in the materials that you have, especially 3D printing, because a lot of flexibles you get into for molding or casting or things like that we don't have options, especially in the early stages of prototyping. And a lot of research is really going into, as you mentioned, with these grippers, very low actuation, but they're able to have a really high grip force, whereas we want the opposite. We want it extremely actuated and almost no grip force. So the literature to really go down that path is also quite limited. So designing this hand that has a lot of the features that are not common in a lot of robotics that are being developed now. But as we've iterated, we've really been able to really take advantage now of so much of additive manufacturing that's been accessible to us to really create a lot of prototypes because we're designing for people who don't know what they need. They definitely people have never been capable catered to before. So we've had to make so many prototypes in order to really get the feedback that we need. And on the more AI front, in terms of our language processing, we had originally thought, AI is so robust at this point, we can just use some Azure products and really develop out a translation algorithm a little bit more easily. But the data that you need for that just isn't something we have accessible to us. Again, tactile signing is so variable and so unique across demographics, across ages, across people with disabilities, and we need to be able to capture all of that. So we had to kind of find people in different parts of the country, in different countries themselves, people of different ages, people of different education statuses, and be able to find these patterns within the language in order to translate between the two. So because of so much of what we're doing just hasn't really been previously researched, we had to kind of start really low, a lot of ground zeros for a lot of what we've been doing, which has caused a great amount of challenges, but also a lot of really interesting solutions as well that have come out of it.
I'm curious, so you obviously, like I mentioned at the top of this, Tatum Robotics won the Pitchfire competition at RoboBusiness just under a month ago. Mike, they had 5 minutes to pitch, so we know everything about their company, of course, right?
But I talked as fast as I could.
No, you did a tremendous job. I would just wonder, obviously, I think the social good aspect of this was probably a big reason, right? I don't think anything ever like this. There's a tremendous number of people who have deaf blindness. What did you hear from the judges as to why you were the winner compared to the 4 other startups who also had really cool products that they're working on?
Yeah, and the other competitors were so incredible with the innovations that they were working on. A lot of them very niche in themselves that a lot of people aren't working on. And I think in speaking with the judges afterwards and hearing their questions, I think the track that we have forward is very clear. I think that because there are so few kind of competitors in this space, and our go-to-market strategy has been very kind of clear in terms of how we can access these grant programs so that the deafblind individuals don't have to pay this out of pocket. These deafblind individuals who most cannot work, And not only that, but what we're taking advantage of that's new. And if we tried to do this project 10 years ago, we couldn't. And the resources that we've used and that we've needed, that we've been able to do at this point because of the technology accessible to us has been quite remarkable. But I think hearing the judges' feedback as well in terms of making sure that the technology is extremely robust before we move it into commercial applications was also very helpful, because I forget which judge mentioned it, but the robotics break all the time. What's that next step? Deafblind people can't troubleshoot. They don't know what's broken or how to fix it. So really that advice in terms of how to really make sure all the boxes are checked before we put this into deafblind folks' home, to make sure that not only is this a really successful robot, but is a positive experience for those trying to use it as well.
So how are they going to call support?
Yeah, no, that's right. If something on one of your, what's the thought right now? If something was to go wrong with the hand, which it will at some point, right? It happens with every single product in the world. What's the way that they'd reach out to you? Would they have to wait for someone to be there that they can tell, or is there some built-in feedback mechanism? What's the thought at this point?
Yeah, we're trying to close the loop as much as possible. So really we're integrating sensors as often as we can. And again, this whole system's cloud-based. So not only can we see when they're using it, we can see what they're using it for. And by integrating these sensors, we're able actually to make sure that if we think the hand's in this configuration, we can actually have a way of checking that. So I might actually even know that it's not working before the deafblind person is able to access that through initializations and by just tracking how the system's working over time. So hopefully, and that's how we perceive it to be working. So hopefully they wouldn't even have to reach out to us. We would already know, but integrating as many features as possible to ensure that if they do have a problem, there's a button on it. And a lot of great things about these grant programs as well that the government has in place for deafblind people to access assistive technology. A big one is iCan Connect in Massachusetts. They're based out of Perkins. Is they also have Crowe there that also helps with maintenance. So they're familiar with the assistive technology and familiar with the needs of the deafblind folks that they service. So not only are we there to support the maintenance, but hopefully that infrastructure already in place through these grant programs will also be supporting with them.
Have you ever seen some of the robotic hand work that's being done at Johns Hopkins University?
Yeah.
So they have a robotic hand that there was a gentleman, I don't know, I forget what, I'm going to mess up the story, so I'm not going to share the details of why I think he had the need for the prosthetic hand, but I think the story is this is like the most advanced or expensive prosthetic hand ever built. and they were testing it in their labs for so many years, and they finally got it to a point where they were comfortable sending it home with this person. So they really wanted to collect that data of how it worked in his everyday life to try to provide real feedback and see where things needed to be tweaked. And I remember it was within the first week that he had it, he woke up and he went to put it on, like, and 2 of the fingers were stuck in one thing. And that's what they did. They remotely tapped into it, right, through the cloud, and they were able to find a software bug. And I think he was trying to play the piano one day and he couldn't, but they just remotely tapped into it, which is smart, right, to build it out that way.
Right. And plus, again, like, there's definitely people everywhere. We definitely wouldn't be able to be in their homes that would go against everything we're doing if we'd have to be in the homes with them.
Right.
But we're also, again, just as you mentioned, like, not only we bring in deafblind people as frequently as possible, because again, their feedback is what's important. So at least once a week, we have deafblind people coming in. We also have very structured validations that we host, often at Mass Robotics, where we're based. And we just had one a couple weeks ago. We brought in over a dozen deafblind folks to give us feedback in the lab, but we're also, the next step that we're actually aiming towards, that we're hoping to use the funding actually from that Pitchfire win, is to really start pilot studies. So not only are they able to use it, when I'm standing next to them, making sure that it works, but if we put it into their home, are they able to access it easily? Are they using it? What are they using it for? And really getting a lot of that feedback as well before we then move into the next stages.
Well, as you started the conversation, you'll have to add that Alexa skill so that the Ring camera knows someone's outside and can alert them with some sign that someone's waiting at the door.
Right. Yeah, what's also really fun about working with deafblind individuals is they just have been so underserved for so long that there's so much technology that's really missing from their day-to-day lives that would very simple technologies that could make it infinitely easier for them to conduct day-to-day activities. And especially as our team of all, young engineers, we're always so excited, like, oh, well, what if we made this technology? What if we made this? And it seems like a population that we could very easily support going forward beyond just communication, but with navigation, with, as you mentioned, just support tools to help them make sure that people in their homes are not strangers.
Right. So what's the next step on your path for the growth of the company?
Yeah, so hopefully the next step, we are planning either for the end of this year, the start of next, are those pilot studies. So we have a few deafblind people who came into the validation a few weeks ago and really understood the device. They understood the goals of it, were able to show remarkable recognition. We were doing fingerspelling trials and people were getting 100% recognition on it, that it was very clear to them the goals and what we were trying to convey. And so we've been working with them in terms of trying to set up these pilot studies. So hopefully we're going to put these devices into the homes of the deafblind folks so they can, again, access ebooks and just some basic functionalities at first to make sure that, again, they can use it and they do use it. And then from there, the fun begins when we integrate that hand into the arm. So this whole time, we've also been developing compliant robotic arm. So after the fingerspelling hand works, which is great, we then have to put that hand onto the arm to do, again, that real signing of the thousands of signs and really make sure that that is safe and that is very functional. And the reason we've separated them out for so long is there's only so many hand shapes in American Sign Language specific. I think there's like 45, and a lot of them are captured in the alphabet. So if they aren't able to receive the alphabet, they really won't be able to understand the rest of the signs. So we've spent years now really making sure that the alphabet is so clear. And at this point, we're at over 90% recognition rate across all people, some people receiving reoccurring 100% recognition rates. So now we feel confident that the next step would be to put that on the arm and really start iterating on that device as well.
This might be the same question, but I'll ask it in maybe a little bit different way, because you never know who's listening to this. I know hopefully you met some potentially valuable connections at RoboBusiness, but to get to those next steps, like what do you need help with? What are some things that maybe somebody who is listening to this knows someone else who can help you out? Like what are some of the things that you're looking for help with going forward?
Yeah, absolutely. One of the main things that we're always looking for help with is just kind of like DFM work. A lot of work that we're doing is kind of constantly prototyping and iterating, but very little work has really gone towards making sure that that device will be robust over long periods of time. And that's something that our system, with these integrated sensors, we're hoping going to get a lot of feedback on that, but also the whole structural integrity of the system. Really need to make sure that, again, if they accidentally put too much weight on it, it's not going to break. It will work over long periods of time. And always, we need more signing data. We need to make sure that this device we can map from multiple different people and we can capture their grammar patterns. So if anyone knows any deaf or deafblind individuals or native signers, please send them our way. We would love to have a chat with them and possibly bring them in for some motion capture to maybe their signs could be on the robot too.
Oh, that's great. And if anybody from Sertronics is listening, let's help out.
Yes.
They could use your assistance. And I think we'd be remiss if we did. You are part of the mass robotics community, right? We know Joyce and Tom and Russ and the whole crew very, very well. Just how helpful and have they been on the journey for Tatum Robotics up to this point?
Yeah, absolutely. And mass robotics has been involved in such an early stage. Right when I graduated, I actually really didn't have, I was starting this project as an engineer, not as a person planning to create a business out of it. And which, look how far that got me. So right when I was about to graduate, actually, the Canadian National Institute for the Blind reached out and gave us a very small grant to keep going, to keep working. They really saw potential in this. And I really didn't know what my next step was at that point. Again, I was not a person who created a business before. I didn't know what that entailed. All I knew was that I needed to keep working. And I found mass robotics just through the internet. And I came in and met Joyce, and she immediately found a great home for us here. We're working also with the Institute for Experimental Robotics at Northeastern in collaboration with them. And they've been so helpful in terms of giving us resources, spaces, and places to also showcase our work, to find these potential, these network partners or these manufacturing partners that can support us. And being at Mass Robotics is a great place to be. We've have so many connections just with companies within the building who, you know, if we have, we're trying to pick out a Hall effect sensor, is there one that you'd suggest? Or places that we can bring in investors and deafblind people to test out the device, which is always wonderful.
Well, I'm not going to speak for Mike. This has been one of my favorite conversations.
Yes,
we've done on the podcast. You're amazing. This is an incredible journey that you're undertaking here. The amount of good that you're trying to do is tremendous. So we wish you all the best. Samantha Johnson, founder and CEO of Tatum Robotics. If anybody out there wants to learn more about what Tatum Robotics is doing, check out, they have some cool, I'm looking at a video on their website right now. I'm not sure if this is the latest prototype or not, but you can check them out at tatumrobotics.com. Samantha, thanks so much for doing this, and I'm sure we'll see you soon.
Thank you so much for having me. Always great to see you both.